So what I'm going to show for you here today are the focusing problems that I've had with this Sigma 50mm f1.4 lens. I bought this lens new from Calumet, and this lens has been back to Sigma twice already for focusing issues, which I thought initially it was front focusing. They sent it back to me twice. The last time I sent it, I actually sent it with my Canon 7D, and they were to calibrate this lens directly with this camera body, and they've been unsuccessful. I'm going to show you here the focusing problems with this lens. So the way I have this set up is I have this focus test chart, which I downloaded and printed in the highest quality that my printer can print. I use this focus test chart to calibrate lenses to cameras that I've converted to infrared. It's a technique that I've used often and very comfortable with using this setup. I've got my 7D with the 50-1.4 Sigma lens. The distance from the lens to the autofocus point on this paper is exactly 36 inches. For lighting, I have 9 800 lumen incandescent bulbs here, and sunshine here. They're about equal distances from the paper. The camera's hooked up to a wired shutter release, which I'll use for almost all of the testing here. Of course, it's on a tripod. We got another tripod for this video camera once I get things set up. All the focus testing is going to be done in live view, and I'll show you how this lens performs here shortly. The microfocus calibration is turned off here on this camera. This is the way they sent it back to me once they calibrated it, even though all my lenses are microfocus calibrated. We're going to use live view for all focusing tests, and I have found this lens to be very inconsistent in the way it focuses. Here it seems to be, I'm using the remote release to focus this lens. Here it's clearly severely back focused. It's focusing way up here. And here it seems to be front focused. It's focusing down here. Now nothing's moving. I'm just refocusing. Back focus again. It's focusing up here. This is soft here. And this looks like it's front focused now. It seems to be crisp down here. And now we are back focused. It's up here. And now we seem to be front focused. It seems to be crisp around the 2 centimeter point. Hopefully you can see this on the video. Here we are severely front focused, with only this 3 being anywhere close to sharp. Now nothing's moving here, so this lens is clearly not precise, and the definition of precision means being able to duplicate a particular phenomenon over and over again. Now we are front focused. Here seems to be sharp around 2, and now we're back focused, and now we are front focused. Anyway, you get the idea, right? Now we are back focused. Let me see if I can get it. And that looks pretty good. That looks like it might actually have it pretty good. It's a little bit front focused. Let's snap this. Let's snap this and see what we have. We'll see what we have for a capture. Front focused. And very soft. Front focused here. So basically you have a lens here that can either front focus or back focus, but never actually focus where you have it pointed to. Interesting, huh? Well, you might say, hey, maybe it's the camera's bad. Well, maybe it is, which is why I have borrowed this Canon 50-1.4 which we shall now mount on this camera and see how it performs in comparison to the Sigma. So nothing else has been changed. Microfocus calibration is still turned off. Now I'm intentionally focusing on the rather than the middle, the more contrasty lines here on the right side, while keeping the 0 point still visible. It gives the lens and the camera a more contrasty target to focus onto, which is important for some lenses. Let's see. Alright, let's see how this lens performs, right? Same setup. Remote release being triggered to focus this Canon 1.4 with microfocus calibration turned off. Let's see how the Canon performs. ISO is set to auto. Generally it comes up at 400 or 100. Looks like a little bit back focus there. A little bit back focus there. A little bit back focus there. It's consistent anyway. We have precision. Anyway, may not be perfectly accurate, but it does focus in the same spot every time. A little bit back focused, right about there. Right about at the 1.5 centimeter mark. That looks actually pretty good. Now it's focusing in the exact same spot. You can see the bars as they oscillate back and forth, that the sharp parts, you could see this lens seeking back and forth here and these bars coming in and out of view. You can see that it zeroes in the exact same spot every time. And yeah, every single time. And I will go ahead and snap this picture. And let's see what it looks like here. A little bit of back focus, but still the zero line is still in the sharp zone for an f1.8 lens. And this is as zoomed up as I can get, and you can see the zero line is sharp. Now remember, this is micro calibration turned off, and with a few bumps of the micro calibration, we can get this lens razor sharp easily. That's what the micro calibration is there for. If you have a lens like the Sigma, which focuses in pretty much wherever it feels like it wants to, micro calibration will not help you. Because you don't know whether or not it's going to front focus or back focus or actually focus where it should focus. Now you might say to yourself, this is not a real world test. Let's try real world focusing. Well, we're going to do that next. So what I've got now is the Sigma lens back on the camera. Camera's of course on a tripod, and I'm using a wired remote release. On the other end of the room, which is about 12 feet, is a picture that is nearly, I would say, exactly at the same level of the camera. It's tipped back maybe 15 degrees. Shouldn't be a difficult target to capture. The room is lit. It's daylight outside. I have daylight coming in through here, as well as four 75-watt incandescent cans. I believe they put out probably 1100 lumens each. Now we're going to test this camera in, quote, more of a real life, unquote, scenario. So we're doing this in live view again. The target is that picture at the other end of the room. And now I'm at 10x on the live view. Well, let's start at 5x. Let's start at 5x on the live view. Now, I have my remote release. We'll try to autofocus here on this target. Looks pretty good, actually, surprisingly. I'm going to go ahead and snap that. And let's play that back. it's not bad. It's a little soft. It's not bad. It's probably the first time I have done that and it actually focused correctly. I will demonstrate to you here that that is a freak phenomenon shortly. Alright, let's try it again. Soft. 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 Now I don't know if it's back focusing or front focusing or what's going on. All I know is that it's not focusing. It's clearly soft. Alright, let's snap that. Let's play it back. And that's soft. Now let's mount the Canon lens. Let's see how that performs. Alright, the Sigma lens is off, the Canon lens is on. ISO is still set for auto, microfocus calibration is turned off. Same exact setup, same exact distances, the only variable being the lens. Sharp, sharp, quite sharp. Now remember, it was giving me a little bit of back focus on the target paper. Now we can get this razor sharp once we get the autofocus calibration set up correctly on this lens, and it won't take more than 5 minutes to do. You can see here, I'm going to snap this picture. We will play this back. You'll see that the Canon lens is focusing precisely and accurately. There we are. That's at maximum magnification. And you can see it's very sharp. Well, relatively sharp. It'll sharpen up with microfocus calibration. Now let's go back to the same image taken with the Sigma lens. Soft, unpleasant, clearly. This is the maximum. Go back to the Canon. Now the Sigma. Now the Canon. Now the Sigma. Clearly the Sigma lens is defective. You hear this stuff on the internet, well, you must have got a bad copy. Well, I don't know. This lens has been in Sigma's hands twice now. If it was a bad copy, I think they would have figured it out and sent me a lens that's working. I am absolutely displeased with this product. It is going back to Sigma for a third time with a copy of this video so they can see what I'm seeing. Hopefully they get it straightened out. If I get a copy back that performs like this performs, I guarantee you I'll be getting rid of it. There's my Canon. There's the Sigma. That's the Canon. That's the Sigma. That's a real world test, folks. That's a real world test. That's what I noticed when I first got it. I took a picture of a wind chime in the back, and the wrong part of the wind chime was in focus. There's the Canon. There's the Sigma. Now, I did try to microfocus calibrate this Sigma based on the characteristics that it more oftentimes front focuses than it back focuses, and I got totally unacceptable results. Anyway, updates later. One last thing I'm going to do actually before I stick a fork in this is I'm going to manually focus the Sigma lens based on the live view image, and just to show you that it's possible to get this sharp. Let me see here. That's the best I can do. That's it right there. Let me snap that. So now I'm going to play back at full magnification, the manually focused Sigma. That's the manually focused Sigma. The autofocused Canon. And the autofocused Sigma. Again, this is the autofocused Sigma, the autofocused Canon, and the manually focused Sigma. So I know the lens can focus. The problem is with the autofocus mechanism, the AI intelligence built into the lens. And I'll send this off to Sigma and we'll see what they have to say.